In this lesson, we will discuss another concept, the concept of differentials. Now, what is a differential? It is not the same as derivative. Actually, differentials are used to calculate the errors in measurement. Now, very often in the physics lab, I ask students to take measurements. For example, I asked 2 students to measure the length of this rod. The actual length of this is 50 centimeters. So I'm going to write this as the actual length, I'm going to say L. So the actual length L equal to 50 centimeters. Now, the first student measured the length, I'm going to call it L1, the measurement made by the first student. Gave me a measure of 50.08 centimeters. Now, a second student gave me a measurement of 49.8 centimeters. Now, there are errors involved in both these measurements. Now, the error in measuring L, we write it as DL. Now tell me, what is the error in the measurement made by the first student? In place of getting 50 centimeters, that student got 50.08. So the DL for the first student is 0.08 centimeters. Whereas, what is DL in the case of the second measurement? The actual measurement is 50. The measured value is 49.8. Student got less than the actual value. And so we would say DL is negative 0.2 centimeter. An error can be positive or negative. And so we will say the differential of L is DL. DL is the error that can occur in making a measurement of the length L. Now, suppose in a particular lab activity, I want the student to use the value of L squared. After they measure the length L, I want them to use L squared to calculate something. Now that means if you make an error in measuring the length, when you calculate L squared, that error is carried on, or it is propagated into this calculation. Now, let's see how much is the error that is involved in calculating L squared. All right, to do that, I'm going to say that the measurement made by the first student is L plus DL. So if I want to take L squared, the student is actually going to calculate L plus DL all squared. Now, can you distribute that for me? That will be L squared plus 2LDL, is that right? L squared plus 2LDL plus the square of DL, is that right? So I'm going to write that over here. DL squared. Now, for the purpose of calculation, is it reasonable to say that because DL is a very small value, in the case of the first student, that DL is 0.08 centimeter. When you square it, it becomes even smaller. So this can actually be ignored. And therefore, we can say L plus DL all squared is L squared plus 2LDL. Now look at this. If there is no error, the student will be using this quantity in the calculation, L squared. Because of that small error DL, in the calculation of the square of that quantity, what is the error involved? In place of L squared, you got now L squared plus 2L dL. As a result of an error dL in measuring this length L, when you computed the square of that quantity, the error became 2L dL. This is the propagated error. That means, what is therefore the differential of L squared? The differential of L squared is 2L dL. The differential of 2L, differential of L squared is 2L dL. Well, that's not very difficult to understand because it is very much similar to the concept of derivative. Is that right? So, let's look at it one more time. We said differential of L is dL. The error in measuring the length L is dL. The differential of L squared is 2L dL. Now, can you connect it to the concept of derivative? Tell me, what is the derivative of L squared, that is d by dx of L squared? That will be 2L dL by dx. Now, in this particular case, we are not measuring relative to any other variable. There is no x in there. So, what all we need to do is just remove this x, and we will read it like this. Differential of L squared is 2L dL. Now tell me, the derivative d by dx of, let's say, y cube. How much is the derivative of y cubed with respect to x? It is 3y squared dy by dx. In finding the differentials, we are not finding the differential with respect to any other variable. We are simply finding the differential. In other words, we are finding the error in measuring that particular quantity. So there is no dx there. Once you remove that dx, we get our differential statement. The differential of y cubed is 3y squared dy. All right, tell me, if you understand that, let me take that away. What is differential of 1 over y? Well, what all we need to do is write down that derivative of this. It will be negative 1 over y squared times dy. That's right. The differential of 1 over y is negative 1 over y squared dy. Okay. In that case, tell me, what is the differential of sine theta? Well, you know that the derivative of sine theta is cos theta. So, the differential of sine theta will be cos theta times d theta. That's right. The differential of sine theta is cos theta times d theta. That means, if you know how to find the derivative of a quantity, you can find the differential of that quantity. All right? Now, let me use another example to illustrate the concept of differential, that is, error in making a measurement, and the meaning of propagated error, and how it is actually an approximation when you use the concept of calculus. Well, consider, for example, a rectangle. Well, I have a rectangle of length x. I'm going to call it length x and width y. It doesn't matter which is length and which is the width. So, a rectangle of length x and width y. What is the area of the rectangle? The area of the rectangle is x multiplied by y. Now, Suppose we say the length has been increased by an amount dx. In other words, when a student measured the length, the student got it as x plus dx. So this dx is an error in the measurement of x. Or simply we can say, let there be a small increase in the value of x. That means the new value of x is now x plus dx. Now, correspondingly, there is an increase in the value of y. We're going to call it dy. So, the x value is increased by dx and the y value is increased by dy. What is the new area now? If you notice, I'm going to construct the new area there. Now, this length, what is this now? That is y plus dy. And this is now x plus dx. Okay, so I can write therefore the new area. The new area is made up of the old area, which is this. Well, this is the old area, which is, we said, a equal to xy. Now the new area is made up of this old area plus the increased area. I'm going to call it dA. So the new area is a plus dA. Now what is that dA? I'm going to divide this dA into three parts. Now tell me, what does this area, I'm going to shade it, and tell me what that is. What is that area? And I'm going to write it over here. So dA is made up of, that is one part of dA. What is that? This is y, and this is dx. So is it reasonable to say that this will be y times dx? Right? Now, look at this now. This is the second part of that dA. What is this area equal to? The length is x, this is x, and this is dy. Therefore, this area is x times dy. I think, let me see if I can use this. It will be x times dy. So, this dA is made up of y times dx plus x times dy. Is that all? There is this bit. What is that? This is dy, this is dx. So this area is dx times dy. So dA is made up of, one more time, our increase in area is made up of this area, which is y times dx, plus this area, which is x times dy, plus this area, which is dx dy. There you go. Now, in here, I told you that the method we are using is an approximation. When you use the method of approximation, this area is so small. Look at that. dx is a very small increase in the value of x. And dy is, again, a very small increase in the value of y. Therefore, dx multiplied by dy is so small, we can discard it. We can get rid of it. Therefore, we can say approximately, the increase in area is y dx plus x dy. So I'm going to write that here. dA, the increase in area, what is the other name that we have for it? The differential of A. if A is the quantity we started with, dA, the increase in area or the decrease in area, doesn't matter. If dx, dy are negative, we will get a decrease in area. So the change in area dA is equal to y dx plus x dy. Now, assuming that this is very small. Now, watch this. I'm going to take this down and I'm going to ask you, use calculus. Use the rules of calculus to give me the differential. The differential of A equal to, use the rules of derivative. It will be x times the differential of y. You see, we can use the rule for differential the same as the rule for derivative. So to find the differential of x times y, we say x times the differential of y, which is x dy, plus y times the differential of x. Y times the differential of x. Look at that. Isn't this exactly what we got in here as well? So, calculus helps us to find the differential in an approximate way. Is that right? Because this becomes equal to this when this dx dy is ignored. That means calculus is actually an approximate method. But it is a very dependable method because in most cases in calculus, the increases we consider are so infinitesimally small that these kind of quantities can be ignored. All right, so you now understand the meaning of differential and how to find the differential of a quantity. Is that right? Let's practice with some examples. All right, let's try this. Find the differential of the function y equal to x sine x when x equal to pi and dx equal to 0.01. Well, what we need to do is use the derivative form, that is, the rules for derivative to find the differential. Tell me, what is the differential of y? We have differential of y is dy. Equal to, we want to find the differential of the right side and use the rule for the derivative applied to differential. How does it go? X times differential of sine x plus sine x times differential of x. All right, so that will be x times, what is the differential of sine x? The differential of sine x is cos x times dx plus sine x times the differential of x is dx. Now you notice on the right side dx is common. We can factor that out and that will give you, let's factor out the dx, that will be dx times x cos x. Change that. Dx times x cos x plus sine x. Now, therefore, we can now find the differential of the function. This is our function y. The error in the measurement of x has been propagated to contribute for an error in the function value. So the error in the function value will be dx times x cos x plus sine x. And we need to find the differential when x equal to pi and dx equal to 0.01. Now put those values in here. So this will be 0.01, that is dx, and x equal to pi times cos of pi plus sine of pi. Replace x by pi and dx by 0.01. What's the value of this? Well, you should know that sine pi is 0, cos pi is -1, so this will be negative pi. That will be 0.01 multiplied by negative pi. And what is that equal to? Well, whatever value that gives, that will be a negative value, is that right? Well, that should be negative 0.031. So, when x equal to pi and dx equal to 0.01, when there is an error in measuring x 0.01, the propagated error in measuring that function is negative 0.031. What that means is, when x increases by this very small quantity, the function will actually decrease by this quantity. That is the meaning of that. Let's try another one. H of t equal to t squared plus square root of t. Find the differential of h when t equal to 2 and dt equal to negative 0.01. The differential of t is given. Find the differential of h. Well, we find the differential of both sides. What is differential of h? Differential of h is dh. So we get dh equal to, tell me what is the differential of t squared? The differential of t squared is 2t dt plus, what is the differential of square root of t? Now remember, you always go back to the rule for the derivative. The derivative of square root t with respect to t is 1 over 2 square root of t. And therefore, the differential of square root of t is 1 over 2 square root of t dt. Well, what all we now need to do is replace our t by 2 and dt by 0.01. That will give you 2 times 2 times negative 0.01 plus, this will be dt divided by 2 square root t. So that will be negative 0.01 divided by 2 square root of 2. Well, you can calculate this on your calculator. And can you do that and give me a value? Well, that would be approximately negative 0.44. That negative 0.44 or 0.044, is that right? Well, check this on your own and make sure that you got it right. Okay, let's do another problem. All right, look at this problem. The measurement of the base and altitude of a triangle are found to be 36 centimeter and 50 centimeter respectively. The possible error in each measurement is 0.25 centimeter. Use differentials to approximate the possible propagated error in computing the area of the triangle. Well, we've got the base of the triangle 36 centimeter. This is the possible error in measuring it. And this is the height of the triangle. This is the possible error in measuring it. Now we need to calculate the propagated error in measuring the area of the triangle. Well, that means we need to first of all draw a diagram and write down a function of area as a function of the base and the altitude. Is that right? So, write the area as a function of the base and the altitude of the triangle. What is that function? Let the base be equal to b and let the altitude be equal to h. It doesn't matter what you call. So that's the base of the triangle, and that is the altitude we call h. Now, the actual value of b, the base, is 36 centimeter, and the error in measuring it is 0.25. In other words, when b equal to 36 centimeter, dB, the differential of b, is 0.25. That's the meaning of that. So the error dB is 0.25 centimeter. And h equal to 50 centimeter, and the error in measuring that h is 0.25 centimeter. The differential of h is 0.25. And the area is 1/2 of b times h. Alright, can you stop the video here and find the differentials of both sides? Remember, the right side is the product of two variables. In other words, the differential of the left side will be dA, and that's what we want. The right side, the differential will be 1/2 times b times the differential of h plus h times the differential of b. That's right. So finding the differential, we get dA equal to 1/2 times b times dh, b times the differential of h, plus h times the differential of b, that is dB. We know the values of b and h. We know the values of dH and dB. So simply replace those values, and that gives you dA equal to 10.75 centimeters squared. The error in measuring the area is 10.75 centimeters squared when you have an error of 0.25 centimeter in the measurement of the base and the altitude. So this is the propagated error. Alright. Now, try a couple of this on your own. Find the differential of the following at the given values of x and dx. Y equal to square root of x plus 1 over square root x when x equal to 4 and dx equal to 0.02. I want you to stop the video and try this on your own now. Don't put it off. Alright, that's the first one. The second one, y equal to 5x to the power of 7 over 5 when x equal to 32 and dx equal to negative 0.1. Now remember, the differential of x to the power of 7.5 will be, what's that? It will be 7.5 times x to the power of 7.5 minus 1 times dx. Is that right? Okay, I have the answers for you. The first answer is this, and the second will be that. Check and see whether you have them right. See, sometimes I could be wrong, so you need to tell me whether really these answers are right. All right. We will now look at absolute error, relative error, and percent error. Now, very often we use this concept in a science lab. In the physics lab, I very often ask my students to calculate the percent error in their calculations. So it's a very important concept. Now, we calculated the error in measuring the area, and that is dA. And that is the absolute error in measuring the area A. Now, this error dA occurred in measuring the actual area A. Therefore, what will you call dA divided by A? dA divided by A is called the relative error in measuring A. dP divided by P is the relative error in measuring P. dt by T is the relative error in measuring T. And If you multiply this by 100, we get the percent error. dA by A times 100 is called the percent error. In other words, the error divided by the actual value multiplied by 100. That's the definition of a percent error. All right, let's do a problem. The circumference of a circle is measured to be 56 centimeters. That's the actual value, with a possible error of 1.2 centimeter. In other words, it can be 56 minus 1.2 or 56 plus 1.2. That is a possible error. If we call C is the circumference, then DC, the differential of C, is 1.2 centimeter. That's the meaning of that. Approximate the percent error in computing the area of the circle. Now think about it. How will you proceed in solving this problem? We need to compute the percent error in computing the area. And we know the possible error in measuring the circumference. Now we need to write an equation. That equation must connect these two known things. In other words, we must connect the area of the triangle with the circumference, or we must write the area as a function of the circumference. Can you do that? Well, you know how to write area as a function of the radius. And you also know how to write the circumference as a function of the radius. Therefore, can you write the area as a function of the circumference? All right, let's do that. Let the circumference be C. Doesn't matter what you call it. And C is given to be 56. And the error in measuring that DC equal to 1.2 centimeter. We need to now write A as a function of the circumference C. Well, this is what we know. A as a function of the radius. Area of a circle is pi r squared. Now, what we need to do is replace this r in terms of C, the circumference. To do that, we write down the equation for the circumference as C equal to 2 pi r, and then solve for r from here. What is r equal to? R equal to C over 2 pi. That means if you now take r equal to C over 2 pi and put it in this equation, we will get area as a function of C. So we get A equal to pi times r squared. R is C over 2 pi. So that will be A equal to pi times C over 2 pi all squared. What's that equal to? We got A of C, area, as a function of the circumference is 1 over 4 pi times C squared. Is that right? Can you simplify that? If you notice, this will be C squared over 4 pi squared. 1 pi will cancel, leaving a 4 pi on the denominator and C squared on the numerator. So we have area as a function of the circumference. What all now we need to do is find the differential of both sides. Now remember, we need to find the percent error. What is the definition of percent error? Percent error is the error divided by the actual value multiplied by 100. All right, we carry that equation with us. Find the differential of both sides. Differential of A is dA. And 1 over 4 pi is a constant. Differential of C squared is 2C dC. Well, we can now divide this quantity by A right away to get dA over A. Can you do that? Since we are looking for the percent error, we first need dA divided by A. That is, this quantity divided by this. That is what dA by A is. Can you do that? So dA by A equal to, this is dA, and this is A. And what is the advantage of writing it like this? Look at that. 1 over 4 pi will cancel there right away. And 1c will cancel, leaving a 2dc on the numerator and a c on the denominator. So that will be 2dc over c. We know dc, we know c. We have been given those values. And we replace those values and multiply it by 100. That will give you the percent error. So dc is 1.2 centimeter, c is 56 centimeter. So dA by A, what do you call that? dA by A is called the relative error. So the relative error is 0.043. Therefore, the percent error is multiplied by 100. dA by A multiplied by 100. That is 4.3% is the percent error. Okay, you can do problems like this, I'm sure. Let's try this one. The period of a pendulum is given by t equal to 2 pi square root L over G. Now what is the meaning of period of a pendulum? Now here I have a pendulum. I'm sure you have seen pendulums. Now I know the shadow is actually blocking. Now what is the meaning of period? If I set this pendulum into oscillation, period is the time taken for one oscillation. Now look at that. If the length is very small, it swings very fast, isn't it? Look at that. It swings actually very fast. In other words, the time taken for one swing is actually very small. But if you increase the length, the time taken for a swing actually increases. That's what this equation means. The period, the time taken for a swing, increases with the length. G is a constant. Well, some of you have heard of G is the acceleration due to gravity. When you drop an object, it accelerates down. And that is the acceleration. It is a constant, so you don't need to worry about it. Leave it like that. So, t, the period of a pendulum, is 2 pi square root L over G, where L is the length of the pendulum and G is the acceleration due to gravity. T, the period, is measured in seconds. Alright, suppose the length of the pendulum is increased by 0.5%. Now you are given the percent error. dL over L multiplied by 100 is given here. Find the approximate percent change in the period. Now we are given the percent error in what? In the length. In dL over L multiplied by 100 is this value. You need to find dt over t multiplied by 100. That is the question. Well, so we are given the percent increase in length. The percent increase in length is dl divided by L times 100. And that is 0.5. Now, can you tell me, if dl divided by L times 100 is 0.5, what is dl divided by L, the relative error? dl divided by L is, divide both sides by 100, 0.005. Okay, Now, since G is a constant, can you rewrite this equation by taking that G out and writing with 2 pi? Now look at the way I wrote it. I can write this equation as T equal to 2 pi divided by square root G times square root of L. That's simple enough, is that right? Because square root of L over G is square root of L divided by square root of G. And I wrote 2 pi divided by square root of G, because that's a constant quantity, times square root of L. When L changes, the period changes. All right, can you now find the differential of this? The differential of t is dt, so the left-hand side will be dt. How about the right-hand side? This is a constant, 2 pi divided by square root G will not change. The differential of square root of L is, we did one like this before, 1 over 2 square root L times dl. So, we find the differential of both sides, we get this dt equal to 2 pi divided by square root of G times differential of square root of L is 1 over 2 square root L dl. Well, what are we looking for? We want to find the percent change in the period. What are we looking for? We're looking for dt divided by t multiplied by 100. Now, can you use this equation? Look at this. This is dt and this is t. Can you write what is dt divided by t? dt divided by t will be this quantity divided by that quantity. Can you write that and simplify? All right, try and do it on your own. Now I have brought all these quantities in here. We need to find dt divided by t, and then multiply it by 100 to get the percent. So dt divided by t is this quantity on the numerator and this quantity on the denominator. So that divided by this. Simplify that. 2 pi divided by square root G will cancel. Now, very often students have trouble in simplifying these. Now remember, this square root L is on the denominator. And this 2 square root L is also on the denominator, isn't it? Because A over B divided by C is A over BC. So here, the only thing on the numerator is dl. The denominator is 2 square root L times square root L. These two will cancel. So there it goes. And that gives you 1/2 of dl over L. In other words, dl divided by 2 square root L times square root L. Square root L times square root L is L. So 2L on the denominator. And I write it as 1/2 dl over L. Well, we know dl over L. That was given to us. dl over L times 100 was given to be 0.5%, and therefore dl over L is this, 0.005. Replace this by 0.005, and that gives you 0.0025 is the relative error, dt over t. Therefore, what is the percent error? The percent error is dt divided by t multiplied by 100, that is 0.25%. All right, that's a good problem. Practice that on your own one more time. All right, now I have a problem for you to try on your own. The profit P of a company is given by P equal to 200x minus 1/2 x squared minus 4/3 x squared minus 500x plus 700. Well, if you notice, profit is revenue minus cost. This is the revenue function, that is the cost function. Well, that's not important for us. You produce and sell X number of things, is that right? And the profit produced in selling X number of things is this. Approximate the percent change in profit. We need to find dP over P multiplied by 100. That's what you need to find. Approximate the percent change in profit when X changes from X equal to 125 to X equal to 122. In other words, the number of items produced is reduced. Now, I have given you the answer. I want you to try it out on your own. Okay. Well,